Imagine a machine that can learn from data. This is the essence of a neural network. In this essay, we'll explore a simple type called a feed-forward neural network using PyTorch, a powerful tool for building these networks. Think of our example, the class, as a blueprint for this learning machine. It defines how data flows through the network and how the network processes that data to make predictions. This blueprint consists of layers, much like the layers of a cake. Each layer in the network plays a specific role in transforming the data and extracting meaningful patterns. We'll break down each layer and its function in the following sections. Let's start with the method of our blueprint. This is where we assemble the building blocks of our network. The first layer we encounter is, imagine you have a beautiful image of a handwritten digit. This layer acts like a scanner, taking that two-dimensional image and unrolling it into a single line of pixels. This transformation is crucial because the next layers prefer to work with data organized in a linear fashion. Next comes the heart of our network, the layers. These layers are the workers of our machine, responsible for finding patterns in the data. Each layer is associated with a layer. Think of as an on-off switch. It helps the network decide which patterns are important and which ones can be ignored. This combination of linear transformations and non-linear activations is what gives our network its power to learn complex relationships. Finally, we use to neatly organize these layers. It's like stacking our layers in a specific order to create a processing pipeline. Data enters the first layer, gets transformed, and then flows to the next layer, and so on. This sequential processing is a hallmark of feed-forward networks. Now that we have our network blueprint, let's see how data travels through it. This journey is called the forward pass. When we feed data to our network, it first encounters the layer, which prepares the data for further processing. The flattened data then enters the first layer, where it's stretched, squeezed, and combined according to the learned parameters of the network. This transformed data then passes through the activation, which acts as a gatekeeper, deciding which information is important to pass on. This process repeats for each and layer pair. Each layer learns to extract increasingly complex patterns from the data. Finally, the data reaches the last layer, which produces the output. For example, if we're trying to classify handwritten digits, this output could be a set of 10 numbers representing the network's confidence that the input image belongs to each digit class. In our network, each layer serves a specific purpose. The input layer, represented by, prepares the data for the network. The hidden layers, formed by the pairs, do the heavy lifting of learning complex patterns, and the output layer, the final layer, gives us the network's prediction. The power of a neural network lies in its layered structure. This hierarchical design allows the network to learn simple patterns in the early layers and combine them into more complex representations in the deeper layers. By stacking multiple layers, we're essentially creating a hierarchy of knowledge, allowing the network to make sophisticated predictions based on the input data. In conclusion, understanding the structure and function of each layer in a feed-forward neural network is crucial for building and training effective models. PyTorch provides us with the building blocks to create these powerful learning machines, and by understanding the principles behind each component, we can unlock their full potential.